Okay, we've completed topic 6 and we are ready to start topic 7. We are going to look at similarity in topic 7. And back first semester when we talked about triangles being congruent, to be congruent meant that we had the same size and we had the same shape. Now when we talk about figures, like in topic 7, we're going to talk about figures being similar. When figures are similar, they are not the same size. Okay, they are the same shape, but they are not the same size. And we're going to talk first about what a dilation is. If you've ever gone to the eye doctor and had your eyes dilated, think about what that means. Okay, well, when you go and you have your eyes dilated, they put some drops in your eyes and it forces your pupil to open and to get bigger. And that's what a dilation is. It's going to change the size of a shape. It says a dilation is a change in the size of a figure that is described by a scale factor. Okay, how much bigger or how much smaller that figure gets, we use a scale factor to describe that. So we have a rectangle here that's A, B, C, D. It is a dilation, with the little asterisk, little comma marks with it, or apostrophes with it, that's the dilation. So you can see this is the dilation, it's a bigger figure. It's got the little marks by the letters, that's the dilation. It's a dilation of this figure, A, B, C, D, with the center of P, so it's in reference to P. How are the side lengths and the angle measures of A, B, C, D related to its dilation? And what you want to do is you want to look and see what happened. Okay, side AD was 2 blocks long in the original picture. And once we dilated it, how many blocks did that same side become? It now became a length of 6. So what did I multiply by to go from the original 2 to the new one 6? Okay, well, we took it times 3. Okay, now we're going to see if that's the case for all of the dimensions. Okay, so if I look at how tall this rectangle is, that rectangle is 3 units tall. So if I look at that's AB, that same side, but I look at the dilation version of it, that's now 9. So did the scale factor remain the same? Yeah, you can see that we took it times 3 to get 9. So this is a dilation and it has a scale factor of 3. That means every dimension of the new rectangle is 3 times as big as the original. Okay, it says since, okay, and it walks it through that. Okay, consider this dilation below. So we have a different kind of dilation here. We now have a triangle, and we want to determine what the scale factor is. The original figure is always the figure that has just the letters. The dilation is when it has got that little mark by the letter. Okay, so it's got A with that little mark. We've seen that before. Okay, so we're going to count the sides. So here we started from side B to A. We started with 2 units, but in the dilation, it's now only 1. What happened to it? Well, instead of saying that it was divided by 2 or it was cut in half, scale factors are products. It's what are we multiplying by. So in that case, the scale factor, what do I multiply 2 by to go back to 1? Well, that's half of it. I'm going to multiply it by the fraction 1/2. And just I'm going to check another dimension here. So I've got the side from A to C is 4 units. So if I go to the dilated figure, that's only 2 units. And again, it was cut in half. That means the scale factor is 1/2. So notice that when the figure gets bigger, like the rectangle up here, we have a scale factor that's greater than 1. We had a scale factor of 3. When the figure gets smaller in the dilation, we have a scale factor that's going to be less than 1. We're going to have a fraction. And that happens to us sometime. So keep that in mind. If it gets smaller, scale factor is less than 1. It'll be a fraction. If the figure gets bigger, the scale factor is greater than 1. Okay, you get a chance in your packet to try a couple of these to do your own drawings. Okay, it says draw dilation ABC with a scale factor of 2. Okay, so a couple of different ways that you can do this. We want to do it on a grid. So what we're going to do is we're going to take the coordinates. So A is located at 2, -1. Okay, B is located at -1, +2. And C is located out here at 1, 2, 3, 0. Okay, so we're going to take the different endpoints of the figure like that, and if I want to use a scale factor of 2, I'm going to multiply those coordinates by 2. All right, so if I take everything times 2, I'm going to take these two coordinates here times 2. That C dilation is going to be at 6, 0. 3 times 2 is 6. 0 times 2 is still 0. Okay, if I take these coordinates times 2, again, that scale factor is 2, so I'm going to multiply the coordinates by 2. That means A is going to become 4, negative 2. 2 times 2 is 4. 2 times negative 1 is negative 2. And I find my dilation for B. I'm going to take these coordinates times 2, and I'm going to get negative 2, positive 4. Negative 1 times 2 is a negative 2. 2 times 2 is 4. So when you're on a graph or a grid, the way to draw that dilation is to take the coordinates of the corners and take it times the scale factor. Okay, just so we get a better view here, I'm going to kind of erase this up, and then they're going to ask you to go ahead and graph that. Okay, I'm going to change colors here. I'll go back to red so you can see it. That C is going to be out here at 4, 5. It's going to be out here at 6, 0. I'm going to estimate where that's at. A is going to be located at 1, 2, 3, 4, negative 2. This is where A, the dilation of A is. And B is going to be at negative 2, positive 4. And make sure you connect your points. Okay, use a straight edge if you want. Okay, that figure that I just drew in red is 2 times as big as the original figure of ABC. All right, always label your dilation with the same letters, but you've got a little mark with it. That's your dilation. It's really hard on a grid like this to be able to count and make these sides twice as big without finding their coordinates and multiplying them by 2. If it's a rectangle like on the previous page where it's straight up and down or side to side, that one you can just count out if you want to. But when it's on a grid like this, use the corners. Okay? All right, last one here. Draw the dilation with a scale factor of 1/4. Since that scale factor is less than 1, I expect my figure to get smaller. Not bigger, but it's going to get smaller. Okay, I still want to find the corners. This is at negative 4, 0. Okay, I'm going to put this down here. So R is at negative 4, 0. Okay, P, that's R. P is up here at 8, 4. And Q is down here at 12, negative 4. Okay, so first we locate where are the corners of the figure that I'm trying to dilate. Now I'm going to take all of those coordinates times my scale factor, times 1/4, times 1/4, times 1/4. Okay, what happens to a number when you're multiplying it by 1/4? You want to do that on your calculator, you can do 0.25, or you can divide by 4. Okay, dividing by 4 is the same thing. So my Q, if I divide each one of these by 4, I'm going to get a new value of 3, negative 1. With R, if I divide these by 4, I'm going to get negative 1, 0. If I divide these by 4, my new P is going to be at 2, 1. I'm going to plot those on my graph. Here's 3, negative 1. That's Q. R is at negative 1, 0. And P is at 2, 1. And you're going to connect those. Okay, you can see that the figure that you just drew is smaller than the original, and it should be because your scale factor is less than 1. All right, you've got a worksheet 7.1a called Dilations. Get to show me your artistic ability. Okay, go ahead and do the best you can with that.